Hi guys, Mr. Wallace here, back with another symmetry lesson for this week, okay? Last video we looked at lines of symmetry. In this video we're going to be looking at rotational symmetry, so continuing with the theme. And as usual, 2 questions on the board. Make sure that you're able to answer them by the end of the video. Otherwise you should be thinking about getting in touch with your teacher, whether that be me or whoever has assigned you the work, okay? So if we get started with this, rotational symmetry is just when, it's pretty straightforward, we take a shape like this and ask ourselves, how many times does it fit back into that position it started in one full rotation? Okay, so how many times is it going to be in this exact position as we go through one full rotation? We'll use this rectangle to demonstrate this. Okay, so we'll grab the rectangle and we'll start rotating it. Okay, and as we go through a rotation, you'll see it doesn't fit into the shape most of the time, but as we get to this halfway point, suddenly it fits back into that starting position. Okay, so that's one time that that's happened so far. We need to get that red dot back up into the top corner. So we're going to keep going, and eventually when we get back to the top corner, there, that's the second time in our 360-degree rotation, it's fit back into that position. Okay, now how we refer to this is we say that we have an order of symmetry of 2. Okay, an order of symmetry of 2. And the one other way that you will sometimes hear this referred to is saying that this has half turn symmetry. Okay, and that's really all there is to this topic. It's just, or these first set of questions you'll look at least, is how often does it fit back into that position as we go through this one full rotation. Okay, if we look at this with a couple other shapes just to demonstrate the process. So first we're going to look at this triangle. Okay, and we're just going to do the exact same thing. We're going to go through one full rotation. How many times does it fit back into that shape it's starting in? Okay, so we start off, we come all the way around here, nothing's fitting, and there we have our first time it fits back into that position. Okay, we keep going, and we should, as we get to around here, find we have a second time where it fits into that position. Okay, it's not exact, that's my drawing's fault, but we'll see how we go. And then as we bring the wee red dot back up to the top where it started, that's us completed our 360 degrees, and there's a third time it's fit back into that starting position. Okay, so for this shape, what that means is we have an order of symmetry of 3, or we can call that having 1/3 turn symmetry. And by now, just as a wee side note, because it will help you going forward, you should start to notice a little pattern developing between this number here and this number here. One last shape we'll look at just to hit this home. Okay, I'm not bothered drawing the numbers on this time. We'll count it up and then we'll put it on at the end. We're watching for the red dot as usual, getting back to the top. Okay, so we've got a 6-sided shape this time, a hexagon. And as we rotate through, you should notice we have 1, 2, 3, 4, 5, and 6. Okay, 6 times it fits back into that starting position. So we have an order of symmetry of 6, or 1/6 turn symmetry. again, look at the relationship between these numbers. And that's all you're going to be asked to look at in this first round of question, okay? Couple of little extra things to keep an eye on before we move on and finish up with this topic, okay? If we look at the exact same hexagon on the left-hand side here, okay, this is the exact same hexagon. The only thing we've done is we've added a wee square into the problem, okay? And they'll do this. Sometimes they'll put two shapes together. They'll give you a slightly more zigzaggy, strange shape. If we think about this shape here that contains a hexagon and a square, again, we're just using this dot to track how far through the rotation we are. You should notice that as we start to rotate, we'll reach a point where the hexagon fits, but the square doesn't, so we can't count that. As we keep rotating, we'll reach a point where the square fits, but the hexagon doesn't, so we can't count that. And we keep going, waiting for that moment where both shapes line up. And it only happens when we get to the halfway point here. Now I've clicked and dragged that, so it's a wee bit off, but we'll go with it. So that's our first time, okay? And if we follow the same pattern through, waiting for those times when everything matches up, you'll see it doesn't happen again until we get back to our starting point with the dot at the top. So, in this case, although both of these shapes would have a higher order of symmetry by themselves, their order of symmetry in this occasion is just 2, or half-turn symmetry. Okay, you need to watch for that when you go through some of the questions. Our second shape here, just to demonstrate, is an arrow. Okay, now as I rotate this arrow, what you should hopefully see is that it doesn't actually go back into that starting position at all as we go through the rotation. It only gets back there as we reach the end of our 360 degrees. Okay, that means it has only reached that position again once, so we say it has an order of symmetry of 1. But what this really means is it has no rotational symmetry, okay? So an order of symmetry of 1 means you have no rotational symmetry, because it's only ever in the position you wanted to watch for when it's back at its starting point. So no rotational symmetry, okay? And at that's all we're really asking you to look at this week, guys, okay? So just going back to the questions again, make sure that you can answer both of these off the back of this video. If you can't, check with your teacher. If you've got questions attached to this, make sure you're having a good go at them. A lot of it will be based on what you've seen here. There might be some trickier shapes, but that's just good practice for yourself, okay? Otherwise, I hope you have a good week, and I'll see you next time. Thanks, guys.